All right, so here we are working on the Chapter 8 practice test, and I have the first two problems done because on number 3 I made a mistake, and I'm just not going to start all over with a blank sheet of paper. I'm just going to kind of keep what I have here. But number 1, it says to find the exact value of the 6 trig functions of theta. So here's my angle in question, and I want all 6 trig functions. So I need sine, cosine, tangent, cosecant, secant, and cotangent. So to do those, I need to know all 3 sides, and because I know the side adjacent to my angle and the hypotenuse, I need to find the side opposite of my angle. So I'm going to use the Pythagorean theorem. So let's say this is a squared plus b squared equals c squared, and I don't know what this is yet. 10 squared plus an unknown, x squared equals 25 squared. And as I solve for x squared, I'm going to subtract 100 from 625. X squared is 525. And if I do the square root of that, I get the square root of 25 times the square root of 21, or 5 square root of 21. So that's how I got this side. Now, sine of this angle would be opposite over hypotenuse. So I have 5 square root of 21 opposite over 25, and I can cancel the numbers outside of a root sign, so I can divide each of these by 5. Square root of 21 over 5. Cosine would be the side adjacent, which is 10 over hypotenuse, which is 25, and that reduces to 2/5. Tangent is side opposite over side adjacent, so 5 square root of 21 over 10, and I can cancel, divide both top and bottom by 5, and I get square root of 21 over 2. Cosecant is the reciprocal of sine. So if I go back up here to sine and I do the reciprocal, I'm going to have 5 over square root of 21. And if I do the 5 over square root of 21, I have to rationalize that denominator. So I need to multiply the top and bottom by the square root of 21. So that gives me 5 square root of 21 over 21. Secant is the reciprocal of cosine. So just flip that over, 5 over 2. And cotangent, if I flip over 2 over square root of 21, I need to rationalize the denominator. So I get 2 square root of 21 over 21. All right, number 2 says to solve the triangle using SOHCAHTOA. So if I'm going to use SOHCAHTOA, that tells me that this has to be a right triangle. So I'm just kind of labeling this. I think the formatting kind of got off a little bit. This is angle A, which is 27 degrees. And I know angle C is 90 degrees. So that leaves angle B, which I'm trying to find. And 27 plus B has to equal 90. So B has to be 63. So now if I want to find side B, if I'm using this angle B, which is let's use angle A. So I know angle A is 27, and I want some trig ratio with the side adjacent and the side opposite, so that would be tangent. So tangent of 27 is going to be opposite, which is 7 over B. And if I solve for B, I'm going to have B equals 13.74, and that would be inches. Okay. Now if I want to find side C is the hypotenuse. I need something. If I'm using 27 degrees as my angle, opposite and hypotenuse, that would be sine. So sine of 27 is opposite 7 over c. If I solve for c, I get c equals 15.41 inches. All right, so now I have all three sides and all three angles. On number 3, this one, I don't have a whole lot of space here, and it says to draw a picture to determine which case it is, but I need to solve for the triangle. Okay, it's not a right triangle. I don't have a right angle, but if I were to draw a picture, I would have something that looks like this, where this is 100 degrees, that's angle A. Here's angle B, here's angle C, B, C, A. It says that side B is 16 feet and side C is 20 feet. And if I look at what I have here, I have side, angle, side. And to solve for other parts of this triangle, I need to use law of cosines. All right, so let's use what I have here and find side A. So that would be A squared equals B squared, which is 16 squared, plus C squared, that's 20 squared, minus 2 times 16 times 20 times cosine of angle A, which is 100. All right, so to find A squared, I need to put all of that into my calculator. So I have 16 squared plus 20 squared minus 2 times 16 times 20 times cosine 100. Now that's going to give me 7.67, and that's what A squared equals. So if I want to find the value of A, I need to do the square root. Now, instead of typing all this back in, I can just type the square root, and to get the answer above the negative key, it says answer. So if I do second answer, it's going to take this value and put it underneath the square root sign. And that gives me 27.697, 27.7. So A is 27.7. 27.7. All right. So now we need to find B and angle C. So I can do this a couple ways. I can use the law of cosines to find angle B, or I can just use the law of sines, which I think is so much easier. So what do I have here? I know that angle A is, or side A is 27.7. So if I use the law of sines, I'm going to have sine 100 over 27.7 equals sine of B over the side opposite B is 16. So I have sine B is 16 sine 100 over 27.7. So to undo sine B so that I can find out what angle has a sine of this value, I'm going to do inverse sine. I'm going to do that on both sides of the equal sign. So on my calculator, I'll do inverse sine of 16 sine 100, and then divide that by 27.7. And my angle measure is 34.67. So that's angle B is 34.67. So I'm going to put that here. And last I need to find angle C. And I can also, if I know this is 100 and this is 34.67, I can take this away from 180. So C is 180 minus 134.67. And angle C is 45.33. All right, so we had to start off using law of cosines. I could use it again to find an angle measure, but it's so much easier to use law of sines and then to use the property that the three angles have to add up to 180. So this was number 3. Number 4. On number 4, I have a triangle. I have an A is 10 degrees, a B is 4, and A is 3, B is 4, angle A is 10. So let's draw this. So here's my angle A, this is 10, and here's B, and here is C. So across from B, I have a 4, and across from A, I have a 3. All right, so that just came from this information here. A is 3, B is 4, angle A is 10. So that's the triangle that it looks like. So in this case, I have a side, and an angle. All right, so if I have side, angle, I am going to use law of sines. All right, so I'm going to do sine of 10 over 3 equals sine of B over 4. So sine of B is going to be 4 sine 10 over 3. And I need to do the inverse sine. So B is going to be inverse sine of 4 sine 10 divided by 3. And that would be 13.39. So 13.39. Now I do need to check to see, do I have one solution or do I have two solutions? All right, so if I have 13.39, I'm just going to write a note here. Check for two solutions. So if I take the supplement of 13.39, 180 minus 13.39 is 166.61. Now, to see if this will work, I need to add this this would be B prime. That would be our second solution for B. So to see if this will work, I'm going to add it to A and see if there's anything left over that C can be. So 166 plus 10 is 176. Oh, so this is less than 180. So I can have two solutions here. So I can say that B prime is 166.61. All right, so just kind of looking at this, I'm going to have two sets of answers. So angle A will be 10, side A will be 3. Angle B could be 13.39 or 166.61. If angle B is 13.39, then angle C has to be 180 minus 13.39 and 10. So I'm going to subtract those other two angles from 180, and angle C would be 156.61. Okay, so this would be 156.61, and then to find side C, I'm going to use my law of sines. So I will use sine A, or sine of 10 over 3, equals sine of 156.61 over side C. All right, so to find side C, I'm going to multiply this and multiply this. So I have 3 sine 156.61, and then I'm going to divide by sine 10. So I'm just going to do those calculations off to the side. 3 sine 156.61 divided by sine 10. And I get 6.85. Okay, so side C would be 6.85. So now, let's say my angle B was 166.61. That means that angle C is going to be 180 minus 166.61 plus 10. I'm subtracting all of that. So 180 minus 176.61, and that would give me 3.39. And that's degrees. That's measure of our angle. And then to find side C, I'm going to still use my law of sines. And I'll have sine 10 over 3 and sine 3.39 over side C. So in this case, C is going to be 3 sine 3.39 over sine 10. Oops, let me do that again. 3 times sine 3.39 divided by sine 10. And I get 1.02. Okay, so if my angle B were 166, the length of side C has to be 1.02. And do we have units for those? Yes, those are centimeters. So I have centimeters here. This is centimeters. Okay, and the angle measures are in degrees. All right, so that was a tough one because we have two possibilities for the length of side B. All right, so now number 5. Let's try number 5. I have A is 100. And side B is 1, side A is 4. Let's see, A is 100, A is 4, side B is 1. So now, here again, I have side, what do I have? Side, side, angle. All right, so here I'm going to do, I can do law of sines again on this one, I think. Nope, I need to do law of cosines. Nope, I can do law of sines. Sorry. So I'm going to do law of sines because I have a ratio here. I have sine A over 4 equals, let's do B, and A is 100. So then I have sine B over 1. So here I have, to find the angle B, I'm going to do inverse sine of sine 100 divided by 4. Because that's sine 100 times 1. So inverse sine 100 divided by 4 is 14.25 degrees. All right, so here it is again. I need to check for that second solution. So the second solution would be the supplement of this. So if I take 180 and I subtract 14.25, I get 165.75. So that would be B prime. Now, if I think about this, the three angles of the triangle have to be 180. So if I have an angle starting already with 100, I can't add 165 to it because that would be too big. Okay, so there is no second solution, woo, on that one. So the only solution that I have for angle B is 14.25. So to find angle C, I'm going to take 180 and I'm going to subtract 100 plus 14.25. And that'll tell me what's left over. And that would be 65.75. Okay, so I have angles A, B, and C. I have side A, side B. Now I need side C. Okay, so I need to find little c, and I'll use law of sines for that. So I have sine 100 over 4, and then sine C, and C is 65.75 over C. So C is going to be 4 sine 65.75 over sine 100. And I get 3.7, I believe. Yep, 3.70. And that would be the length of side C, and that's measured in inches. All right, so that was number 4. So sorry I didn't put it on the sheet. I just didn't have enough room, and it would have looked horrible. When I did my practice, my notes, it looked all squeezed in there, and I didn't have enough room, so that's why I did on another sheet. So now looking, we have 3 more story problems here. So number 6 gives us a picture. This is really hard to see, so I'm going to draw this triangle here off to the side. It says, how wide is the river? So we're finding this width, so that's what we're finding. This says this is 25, and the length down here is 50 feet. And it does say that it's a right angle. So if I want to know the length of this side, and I'm using this angle, and it's a right angle, I'm having the side opposite and the side adjacent. So I can just say tangent of 25, zoom back out, tangent of 25 equals opposite x over 50, and x equals 50 tangent 25. And that is simple in the calculator, so x is 23.32 feet. And that's the width of the river. All right, that was an easy one. Excuse me. Number 7, given the image to the right, what is the distance between the 2 houses? So let's look again. So here I have house A and house B. So A, B, C. And I'm finding the distance between the 2 houses. I do know that this angle is 35, this angle is 50, and I can figure out this angle here, 35 and 50 is 85, so this angle is 95, so that they add up to 180. So this is what I want to find. Oh, and by the way, I do know the distance between these 2 houses is 100. All right, so I'm finding x. If I use law of sines, I can have a ratio with these 2 values and a ratio with these 2 values and find x. Okay, so I know that 95, or sine 95 over 100 is the same as sine 50 over x. All right, so if I want to get x by itself, I'm going to have 100 times sine 50 over sine 95. And if I put that in my calculator, This gives me 76.90 feet. And that's going to be the distance between house A and B. And then part 8. Given a picture of Wrigley Field, the distance from home to the fence, dead center, is 400 feet. How far is it from the fence to third base? All right, so again, this is hard to see, but home plate to this fence is 400 feet. And now I want to know, oops, dead center, that would be right here. Now I want to know how far is it to third base. All right, so I'm going to draw this over here. Here's center field. Here's home plate. This distance from home plate to third base is 90 feet. And this is what I want to find. All right, so one thing that this doesn't really tell us, and hopefully we'll learn, hopefully we would know that this is a square. So right here is 90 degrees. So here I'm going to have 45 degrees as this angle. So this angle right here, I don't know, but I do know that this length here is 400. So I have a side, an angle, and a side, which means I'm going to do law of cosines. I'm going to zoom back out. Okay, so I have 90 feet, a 45-degree angle, and then this is 400 feet. And I want to find the side opposite of my 45-degree angle. So this is going to be x squared equals 90 squared plus 400 squared minus 2 times 90 times 400 times cosine of 45. All right, so I'm going to make this a little bit easier on us. Cosine 45 is 1/2. So if I have 1/2 and 2, those are going to cancel. So I'm going to do 90 squared plus 400 squared minus 90 times 400, and that's going to give me this x squared. And now to find x, I'm going to do square root of my answer, and I get 363. But it should be, I think I made a mistake here. Let me just do this again. 90 squared plus 400 squared minus 2 times 90 times 400 times cosine 45. And then inverse square root of my answer, and I get 342. That's better. 342.33 feet. And that's from third base to center field. All right, so that's what we have. Again, here is just all the formulas that we've used for non-right triangles. just all in one place. There you go. And good luck on your quiz.